Uh, okay, so we have seen few examples, some one or two more we will see. Small example, for example, your this thing, example 1.9, right? That how much energy does a 200 watt electric lamp consume in 2 hours, right? So expression for energy is given as your, you know, that it is your P into T, right? So basically it is watt hour. So this is power and this is your time. So 200 watt and it is for 2 hours. So 200 into 2, so 400 watt hour, right? But we know that joule per second is equal to watt, because we have seen P is equal to dW by dt. W is the work done. So in joule, so it is joule per second, right? Therefore 1 hour is equal to your 60 into 60, 3600 second. So this is 200 into 2, so 400 into 1 hour, this is hour, right? So 1 hour is equal to 60 into 6, so this much of joule, that is 7,20,000 joule, and is equal to your 720 kilojoule, because joule per second is equal to watt. As soon as you make this watt hour into watt second, we are making this one watt second, because our 1 hour is equal to your 60 into 60, so 3600 second multiplied by this 200 into 400. So this much of watt second, and joule per second is equal to watt. So joule is equal to watt second. So this much, that means this unit actually watt second is equal to this joule is equal to 720 kilojoule. A small example. Now another example 10. This is look, whenever we are taking time function here, it is we are anyway we are interested for initially for the DC circuit, but when we will go for single phase AC and 3 phase AC circuits, at that time detail we will learn, but little bit idea, little bit of flavor you will get here, that much. So for example, example 10, it is given derive an expression for the power for the voltage source shown in figure 1.12. This is your figure 1.12. Also compute the energy for the interval t is equal to 0 to t is equal to infinity, right? So this is the figure circuit element, right? Now this is the voltage source. Now current I is equal to, is given 2 into e to the power minus t ampere. This is the current I is equal to 2, it is a time function. I is equal to say 2 into e to the power minus t ampere, and this voltage V, it is equal to 12 volt. So question is that first thing is that this is a voltage source and current entering into the positive terminal, right? Current entering into the positive terminal, but in this case just power expression will calculate that P is equal to that V into I. Therefore current enters the positive polarity, hence we can compute power as P is equal to VI. So it is V is equal to 12 volt, it is 12 volt, right? And I is equal to 2 into e to the power minus t ampere. Therefore it is 12 into 2 e to the power minus t, that is 24 e to the power minus t watt. This is a time function. Later we will see in AC circuit time function we will see, but just to give you a flavor. So expression for energy transferred is given by, it is given in between time t is equal to 0 to t is equal to infinity. So here that means your what you call energy transfer is given limit 0 to infinity P into dt, right? So P is power and t in terms of time second. So what second if comes, it will be joule then, right? So it is 0 to infinity 24 e to the power minus t dt. So you integrate this much of joule, you integrate this, so it will be minus 24 e to the power minus t 0 to infinity. Put these values, you will get it is 24 joule, right? So expression for energy transferred, it is actually 24 joule. I think this is simple thing, it is understandable to all of you, right? Slowly and slowly you have to understand now each and everything. So active and passive circuit elements. So an electric circuit is simply an interconnection of the elements. Earlier we have discussed about this, right? So circuit analysis is the process of determining the currents through the elements or the voltage across the elements of the circuit. Either you have to find out the current through any element or the voltage across these elements, right? So that is our circuit analysis. So basically there are two type of elements found in electric circuit. One is active elements, another is passive elements. Actually active elements are those which are not passive, or in other way passive elements are those which are not active, something like this, right? By considering the energy delivered to or by them, right? So a circuit element is said to be passive if the total energy delivered to it from the rest of the circuit is always non-negative. That means it is, I mean it can be 0 or positive, right. So, a circuit element is said to be passive if the total energy delivered to it from the rest of the circuit is non-negative. That means that that suppose energy is equal to given for any initial time t0 to t, p into dt is energy, because p is power and time. So, what second actually is equal to joule. So, this t is equal to t0 t, so p is equal to v I say t, but mathematically you can represent like this. So, t0 to t limit, it is v I dt, it will be greater than equal to 0, then you can say it is a passive element. Of course, an active element is one that is not passive, just opposite, right. So, this is equation 1.10 first chapter. So, equation 10, right, it does not hold for all time. In general, an active element is capable of generating energy, where passive element is not. Active element, it will generate energy, but passive element it cannot generate. For example, that passive elements are resistors, in general resistors, inductors and capacitors, these are actually passive elements, right. An example of active elements are, it is generators, batteries and operational amplifiers. So, these are certain things you should keep it in your mind. So, passive elements are resistors, inductors or capacitors, and active elements example are generators, batteries and your operational amplifiers. So, in this section we will be familiar with some of the your what you call that important active elements. So, the most important active elements are voltage or current sources, right. So, that generally deliver power to the circuit connected to them, either voltage source or current source. Yeah, just I would like to tell one thing, in that introduction video I mentioned that thing that we will only handle independent sources, but let me tell you, later I thought that your dependent sources also will be covered. It is very simple thing, then everything will be complete, right. So, dependent source also will be there, but very simple, later you will know, very simple. So, both your independent and dependent, both sources will be considered, right. So, there are two type of sources, independent and dependent sources. We will consider here both, although in the introduction video I said only independent, later I realized no, both will consider, right. So, an independent voltage source is basically a two terminal element. For example, your this is a voltage source, a two terminal element, right, and symbol I will come to that later, right, and that maintains a specified voltage between these two terminal. Between this terminal, it is this voltage is specified, right, between these two terminals, right. The voltage is completely independent of this voltage, is completely independent of the current, right, or it is independent of the voltage of some other parts of the circuit, right. So, physical sources such as generator and batteries may be regarded as approximation to ideal voltage sources. So, either generator and batteries you can it can be regarded as your ideal voltage sources, that way we will think. Now, one is, look at the symbol, here one circle is there and it is plus minus. This can be represented by DC as well as AC, both you can. This is one of the symbol, right, not AC, I should say time varying, I will say time varying, right. So, either plus minus, it can be regarded as your DC source or time varying, and this one when we will make that one your what you call plus minus, if you make the larger your dash line, larger one, larger continuous line is plus and smaller one is minus. So, this is actually a pure DC source, right, but this one it can be used for constant or time varying voltage. This can be, this symbol is meaning for both. So, if you use this symbol also absolutely correct, and if it is a pure DC, then this one also can be used for a pure DC. So, these two are symbol for your independent voltage sources, right. So, similarly, so can be, so that is why whatever I said that can be used to represent DC voltage source, but the symbol of this thing can also be used for a time varying voltage source, both DC as well as time varying, both can be made. So, an independent current source, when it is independent current source, again it is a two terminal element, it is a two terminal element that provides a specified current, right, your what you call completely independent of the voltage across the source. So, this current source, whatever it is there, it is completely independent of the voltage across the source, right. So, this is totally, this is a symbol of the current source, and this current source, this symbol is true for both DC as well as AC, right. This symbol is true for both. AC you will see later. So, So independent sources are usually meant to deliver power to your external circuit. So this symbol, this figure 1 is true for both DC and AC, I have told you, right. So example, I is equal to 2 ampere, if I is equal to 2 ampere, say if I is equal to 2 ampere here, right, then it is a pure DC source, and if I is equal to say 2 sin 100 pi t, so it is an AC current source, but this symbol is same for both DC as well as AC. When we will go much deeper, we will know all these things in detail, right. So not making much exercise here, wherever necessary I will do it. So this thing is understandable, right. So now dependent sources are usually, dependent sources are usually a diamond shape. So for example, this is plus minus, this is dependent current source, right, and an arrow is shown upward here, right, just for the purpose of example, and this is your dependent voltage source. That means dependent voltage source means this voltage, whatever it is, it may be function of current in the some part of the or some branch of the circuit, or maybe a function of some voltage across some elements of the circuit. Similarly, this current is maybe the function of some other branch current in the circuit, or maybe function of some voltage across the your circuit. So these are dependent, so these are not ideal, these are not constant, these are dependent sources. So symbol is, this is diamond shape, and this symbol is your like this, that is a dependent source, this is dependent voltage source, and this is dependent current source. So many things are written here, but whatever I am telling, meaning is same, right. So and a dependent or controlled voltage source is similar to an independent source, except that the voltage across the source terminal is a function of other your what you call other voltages or current in the circuit. For example, look, this is actually your dependent voltage source. Like V0 is given 2 into Vx. In general, you can take A into Vx, right. A may be 1, 2, 3, 4 whatsoever, or below less than 1 also. So it is some 2 into Vx is taken. For example, this Vx actually is the voltage in the circuit across some other branch, right. But just symbolically it is shown that V0 is equal to Vx. If Vx changes, then V0 will change, right. So this is actually called voltage controlled voltage source, because this V0 is function of this voltage across some other element in the circuit, say X. So that's why it is written say Vx. So this is actually the voltage voltage control voltage source. So because V0 is a function of Vx, and this Vx is the voltage of the circuit across some other element X, right. This way you imagine at this stage. Similarly, this is also this voltage V0, it is taken 3 into Ix. Sometimes we call this is a gain parameter 3. It is 3, it may be 4, 5, 2, 1.2, it does not matter. Just for the purpose of explanation, we have taken V0 is equal to 3 into Ix. The Ix is the current through some other branch, some branch X, say, and if Ix is changing, so V0 is changing. That means it is actually called current controlled voltage source, because this voltage source V0 is function of the current. That is why it is called current control voltage source, CCVS, say in short, and it is voltage control voltage source VCVS, right. So this is actually dependent source, that your V is equal to your V0 is equal to 2 Vx, or V0 is equal to 3 Ix. These are called dependent source. That means V0, in this case it may be function of voltage or maybe function of current also, right. So this is when it is function of voltage, it is called voltage control voltage source. When it is function of current, it is called current control voltage source, because V0 is a function of the current. I hope this is simple thing. I hope it is understandable to you. Similarly, that means whatever I said, that everything is written here. This is figure 1.6a 1.ab. So whatever I said, everything is written here. So I am not reading or not telling further. Everything is written here, right. And only thing is that here in this case, whenever it is you are dependent on the current, so this parameter, this 3 we call the gain parameter, right. So now next is this is your what we call voltage source. Now current flowing through a dependent current source is determined by a current or voltage elsewhere in the circuit. For example, this is say current control current source. So this is a dependent current source. This is I0 is equal to say 2 into Ix, say 2 is, it is 2 I have taken, it may be 3, 4, less than 1, whatever it is, it does not matter, right, but for the purpose of explanation say it is 2 into I x. So, this is actually current control current source, because this I 0, the current is function of the current I x. I x may be the current of some element in your branch in current I x flowing some branch x, say. So, this actually that I 0 is equal to 2 into I x. So, that means it is current control current. So, whenever this is function of this one, it is function of current I x. So, it is current control current source CCCS we call, right. Similarly, this current when I 0 is 3 V x, it is voltage control current source, because this I 0 is function of the voltage V x. So, and this V x is maybe it is the voltage across across the branch say x, right. So, I 0 and 3 your what you call this 3, I have taken 3, it may be 1, 2, 3, 4, it does not matter, this is also called gain parameter. So, I 0 is equal to 3 V x, and this is your what you call voltage control current source. And another thing is that whenever we are showing this is plus minus, it is shown, right. Similarly, for the current source, whenever this arrow is upward, this I mean it is that means current is leaving this terminal. So, this arrow, this is your what you call that arrow upward means the current is leaving upwards. I mean current is moving flowing upward. So, current is flowing like this, right. So, this I mean if it is like this, just hold on, right. So, this is the guy that your what you call current is flowing like this. Similarly, this is your what you call that your upward this thing direction. So, current is flowing like this, right. So, this is actually your upward direction is shown. If it is downward direction, then naturally it will be reversal, direction will be in other way. So, this is the meaning that your upward. So, this is your what you call current source, right. Just hold on. So, this is actually this current source. We are now we have seen that your what you call dependent voltage source and your dependent current source, both are dependent on either voltage or current, right. Now, so whatever I said, that is your in about this circuit, everything is explained here, So, it is simple thing. So, not I mean this thing going not to repeat this again, right. So, that means the control voltage sources and control current sources, right, are useful in constructing the circuit models for many types of real world devices, such as your transistor, just hold on, such as your transistor, then your transformer, then electrical machines and electronic amplifiers, right. So, these are the your what you call that this kind of this thing your real time real world application. Just hold on. So, this thing, so there are 4 such sources we have shown. So, voltage control voltage source we call VCVS, current control voltage source already we have shown CCVS, then current control current source CCCS, and voltage control current sources VCCS, right. These are the 4 things. Next, you take another example. So, determine this circuit is shown, this is say example 11. So, determine the power absorbed or supplied by each element in figure this. Now, little bit of we have to understand little bit. For example, if you see that the current I is equal to 6 ampere, this is 6 ampere. Now, voltage is given V is equal to 20 volt plus minus P1 P2 here, this is another element P2, this is P3 and this is P4, this is another dependent current source. So, these are the you have to find out power absorbed or power supplied, right. Power supplied must be equal to power absorbed. If you see something is not matching, then somewhere something has gone wrong in calculation. Now, this is actually some element. So, plus minus polarity has been marked. Here also voltage source polarity plus minus has been marked. Here also polarity plus minus has been marked, right, and this is your current is shown upward, and this current source is showing 1 upon 6 I. That means, if I is equal to 6 ampere here, I is equal to look 6 ampere. If you put I is equal to 6 here, it will be actually 1 ampere. Now, in our previous discussion we have seen that when that your current leaving the this is a voltage source, current leaving the your positive polarity or positive terminal, that means power is supplied and sign will be negative, right. So, in this case if you see that this I1 current is coming out from the source, so it is actually leaving that your what you call that leaving this plus terminal, that means power supplied conventionally negative. Therefore, P1 will be your minus 20 into 6. So, minus 120 watt it will be power supplied. So, that means, if you look at here that P1 is equal to 20 into minus 6, that is minus 120 watt, that is a supplied power. So, whenever current is leaving plus terminal, it should be minus, I told you earlier, that will be power supplied, right. And this current I is equal to 6 ampere according to this polarity entering into this circuit and into this element, right. Therefore, this circuit will absorb power because current entering at the positive terminal. That means, power absorbed should be 12 into 6, P2 is equal to 12 volt into I is equal to 6 ampere. So, it will be your 12 into 6. So, your this thing it will be 72 watt. So, here you see that in that your P2 is equal to 72, that is power absorbed power, that is P2 is equal to 72 watt. Again you come to this circuit, that again 7 ampere current is entering into this terminal. So, it is a positive, that means, as current entering into the positive terminal, it will be power absorbed and voltage is given 8. So, 8 into 7. So, P3 will be 56 watt power absorbed. So, it is made here that P3 is equal to 8 into 7, 56 watt, right. So, it is absorbed power. Now, come here, this is the current source. Now, question is that this is the current source. Now, here I am just making it here only, right, making it here. So, I is equal to 6 ampere, that means, this one is equal to your 1 by 6 into 6, writing here, that is your 1 ampere, this is 1 ampere. Now, question is whether it your what you call it deliver or absorb power. Now, look, this terminal is plus, this is minus, that means, this is a simple wire only, this is simple wire only, right. So, that means, I can mark it here, this is plus and this is minus, because this is plus minus, nothing is there. So, this is plus minus, and this current is upward, means current is your what you call this 1 ampere current is moving like this, flowing like this. That means, current actually leaving this terminal, the plus terminal. As soon as it leaving means it is power supplied, right. Whenever current leaving the plus terminal, this power, it is power supplied. So, that means, this sign will be negative, but its current here is 1 ampere, current here is your what you call 1 ampere. Now, what is the voltage? Now, if you come to this if you come here, look that voltage across this it is 8 into minus 16, I told you, because current is leaving the plus terminal. So, it is your minus 1 and I is equal to 6 ampere. So, it is coming minus 8 watt supplied power, that means, here you come, just hold on. So, whenever I was explaining this, this one this is your what you call that this voltage actually, suppose this is plus minus, that means, this point is A, this is B, then nothing is there. So, this point is A, this is also B. So, this voltage actually if we make like this, the VAB is equal to say 8 volt, right. So, same voltage here also 8 volt, but current I is equal to your 6 ampere, here I is equal to 6 ampere is given, look at that pointer I am making 6 ampere. So, basically this one will be 1 upon 6 into 6, that is your 1 ampere, right. And I told you the direction is upward. So, current is flowing through this, and this is plus minus means this is plus, this is minus, right. Therefore, that current is leaving the plus terminal, because this is plus, this is minus, it leaving the plus terminal. So, if it is so, that means it is power, so your what you call power supplied by the source, it will be actually your this thing will be minus your 8 into 1. So, that is your minus 8 watt, right. So this is the concept. Okay, thank you very much. We will be back again.